In this video, we're going to cover binomial trees, and we're going to look at the concept rather than the maths behind it. We're going to look at it in relation to actuarial derivatives pricing. Let's first look at what is a binomial tree. Well, the definition of binomial means it just consists of two numbers or two terms. So now we know that a binomial tree is a diagram where each option splits into two, as we can see below. A splits off into two, and then B and C do the same as well. Obviously, this can happen again and again, but for simplicity's sake, we'll just leave it at two splits. So what is the idea behind the binomial tree? And we're looking at this in relation to pricing derivatives. So first, we have to do a refresher of something we've covered in previous videos, which is replication, in particular two-state replication. As we can see, to price a derivative at state 0, what we need to do is we work back from the two states that we know it can become. And these states have known values, and we put them in the dark color. So using these known two states that it could become, we can figure out the unknown state at time 0, and therefore pricing the derivative, just like this. Yep, so this is more the idea behind it. So using this replication technique, we can use this for the binomial tree as well. Since we know the end of the tree, we know D, E, F, and G. This is when, for example, a European call option could be exercised at maturity date, and we'd know the exact value. So if we split up the binomial tree, we can split up the one we have into three different splits. And again, we can sort of see, now it looks awfully similar to the two-state replication we had. Using our known values of D, E, F, and G, we can work backwards and find out B and C, just like. So now we know what B and C are, we can again use replication and find out the value A. So now you've sort of seen how we've worked back from what we know at the maturity date for a derivative option. We worked back and found out what is the value of it now, which is time A. Again, this could have multiple splits. You could have 10 different splits, and what you do is each time you'd break up each split and you'd replicate backwards. Right? So, and that's the idea behind the binomial tree concept. Okay, so hopefully this made a bit of sense with my understanding of binomial trees. It is a very simplified approach. However, hopefully it helps you price derivatives using binomial trees by understanding the process a little bit better.